Good afternoon. My name is James DeMeo, and I must apologize for not being able to be there with you at this 12th annual conference on the physics, chemistry, and biology of water. And I want to thank very much Dr. Jerry Pollack for his kind invitation, and my apologies that I couldn't get things straightened out regarding passport requirements for entry into Bulgaria. My talk today is on anomalous living spectrographic changes in water structure, and it's the result of many years of investigation of these phenomena. I'm going to show you some interesting slides that are selected from my larger slide set on this very interesting issue of blue glowing phenomenon in water and in nature. Next slide. One of the things I want to start off is speaking about the cosmic nature of what I believe is going on with water structure. I don't believe it's merely something isolated to water molecules, but that there is something going on in a larger space around us, and indeed even out into cosmic space, that functions through water in a very primary way. And this is emphasized by recent discoveries in space science on the discoveries about cosmic water. If you go back 50 years ago, nobody imagined that water might be the most abundant molecule in the universe, which is a current way of looking at things. We know today that there are moons, comets, planets, ice planets, nebulae with water ice is present, and major massive quantities around some quasars. By this NASA press release that I'm quoting, it says this is another demonstration that water is pervasive throughout the universe, even at the very earliest times. So this is really quite amazing and new discovery. Next slide, please. Here I want to show you two opposing but very similar water bodies. We see on the left glacial water accumulated in shallow pools on the surface of glaciers. This is not uncommon. This is the Knik Glacier up in Alaska. And on the right is the Morning Glory Pool in Yellowstone Park. Very famous, rather small pool of water, but notable for its blue color. And in both cases, the blueness is quite transparent. It appears to be in the water itself, not something that's merely on the sides of the containment of the rock or of the ice surrounding it. And this begins to raise questions about the legitimacy of claiming that this kind of thing is merely due to light scattering. They often talk about microbes in these waters, which you would expect blue glowing microbes to make the water opaque. But in these cases, what we see is very, very transparent water with no apparent abundance of microbes. Certainly there are going to be some in there. But is that what's giving it this kind of blue color, which, as I said before, does not appear to be have enough depth, really, to argue for light scattering alone? Next slide. And here's another case which is quite common. On the upper right, somewhat cloudy conditions, you can see these chunks of ice sitting on the surface which have a bluish coloration. And on the lower left, you can see large chunks of ice and a glacier with a very deep, profound blue glow. And I've contacted a lot of the photographers here, and this is nothing special, filters being added to the cameras. These are all basically either old Ektachrome slide film or they are digital cameras of one kind or another. Next slide. We can extend this out into the atmosphere as well. On the upper right, you see a picture taken with Ektachrome slide film some years ago by a Greek photographer of a phenomenon that I have spoken with several Greeks who have seen this with their own eyes. It is a blue glowing kind of a transparent haze that exists sometimes up in the northern mountains of Greece. And it's apparently frequent enough that it appears in travel posters and that sort of thing, which is where I first saw it, and I was quite amazed. And in the lower left, this is looking down into Crater Lake National Park, which is very close to where I live in southern Oregon. And in this case, the water looks as if there has been blue dye poured right into it. It is so fluorescent in the blue color, and I really do hope that the slide you're being shown really shows this. If it doesn't appear as spectacular as I'm describing it, you should download the PowerPoint from the Water Conference website and take a look at it on your own computer screen at home. Now again, the one on the left, since it is a deep body of water, Crater Lake National Park, you could invoke the light scattering theory without too much difficulty. But on the upper right, it becomes increasingly challenging of that theory, in my opinion, especially since the blue color in both of these cases is much more intense than what you see overhead in the sky. Now, sometimes if you go to Crater Lake Park, you can see that the blue sky above it is really quite blue also. But at other times, the water in the park lake is got a deep, deep blue color where your eyes get the sense that this is some kind of a fluorescent radiation coming off the lake surface or out of the water itself, which is darker in blue color than the sky overhead, which might be a milky kind of a light blue. Next slide. You can also see some of this in certain flowers, certain blue flowers, which are today being noted by the biologists as being highly attracted to bees. These flowers emit ultraviolet, near ultraviolet, as well as dark blue colors which attract the bees. And here I've been able to make some photographs of this. As you can see in the right side, there are two examples, one taken with a standard method of photography in the lower right, and the upper right shows the same set of flowers but with a slightly different photographic technique. You can actually see the blue fields around the edges of the flowers, and I believe those are bluebeards flowers. And the one on the left center is a hypatia, which was photographed by a nature photographer, and he didn't know what it was. He just said he was walking through the forest and he saw this late in the evening and was just stunned to see all these blue glowing flowers, and so he took a picture. And this kind of thing is not unusual among nature photographers, people who spend a lot of time outdoors. Next slide. Now we know that hot springs often have healing waters and with a blue glow, and this is true of Lourdes in France, and I've seen a few of the natural mineral hot springs in the United States which have this kind of a blue color, and it is something that is remarked upon by people as part of what makes the water healing in nature. And certainly the mineral content gives rise to certain kinds of healing phenomena, but I would postulate that it's a charge of energy in the water. Now the question is, what kind of energy are we speaking about here? Next slide. But again, let's go back to the light scattering theory as per Lloyd Riley. That comes back to us from the early 1900s, and I would say, as I write here, for some natural atmospheric, Earth surface, and physical, chemical, biological, and even possibly astronomical phenomenon, there's a correlated far ultraviolet absorption and a near ultraviolet visible blue fluorescent property observed in the charged, excited states of water. Now, this argument that I've laid out here is something that I can put empirical evidence to, not only from my own work, but Dr. Pollack's lab has produced basically the same kind of evidence that I'm going to show you, but in a completely different context. Next slide. Now, this is heresy. This is the Wilhelm Reich orgone energy accumulator. And this is a small one. It's a desktop accumulator that I had specially constructed. And inside it, you can see the door is open to this thing, and there's a bowl of water sitting in there with about a couple of centimeters of water. The accumulator is made of alternating layers of dielectric material and ferromagnetic material. It is very specific in its construction. You can't just slap together any old metal or material and get these things to function correctly. And I also want to say this is not to be confused with the ridiculous orgonite pyramids and little pendants and trinkets that are sold on internet and eBay today. Of course, that makes a big ridicule of what I consider to be very serious research. And also the slander of Reich from Wikipedia and the skeptic clubs and the mainstream media people, that has to be discarded as unscientific attacks. And I think most people doing water research will know automatically what I'm speaking about. Next slide. Here you can see the setup we have for absorption measurements at my laboratory using ocean optics, UV visible USB 4000 spectrophotometer, and we're using 10 centimeter quartz cuvettes with solarized ultraviolet transmitting fiber optics, going from the light source A to the cuvette holder B into the spectrophotometer C, and then the data from the spectrophotometer goes to the computer D, where it is graphed out by specialized software. Next slide. And here you can see a couple of graphical displays of water absorption in orgone energy charged water. This is a dish of distilled water that is simply placed inside of an orgone energy accumulator for a couple of days, as per that picture I just showed you. And we compare that to a control dish of water, the same distilled water from the same jug, which is put underneath a cardboard box on a table some distance away from the accumulator. In the upper part of the graph, you can see the controlled distilled water does develop a little bit of this spectral reaction in the on the left side of the graph in the ultraviolet, but the orgone-charged water gets a higher absorption of ultraviolet as seen in the spectrophotometer. This is very reproducible. Sometimes the control water does not show any reaction at all, and the orgone-charged water shows a very strong reaction. And another way of looking at it is in the lower graph. By subtracting the two curves, you can see that there's a differential which can be extracted with a peak of around 280 nanometers. This is after 2 days of charging. It's a dynamic phenomenon that increases over time and is very reproducible. Next slide. We see the graphic showing 6 days of charging and the changing in the shape of these spectral absorption signatures. On the upper left, you can see that there's a flat line. This is at the beginning of the experiment where we have the control dish of water and the orgone-charged dish of water. Both are starting out as no difference between them. The upper left graph is after 2 days of charging. You can see it's already, the accumulator has outpaced the control water with a peak of around 265 nanometers. In the lower left, this is after 4 days, 250 nanometers, peak increased in intensity. And in the lower right, you can see the result is after 6 days. The peak is migrated off a little bit to the left, but the intensity has increased. Again, there's something going on in nature that will allow water to obtain a little bit of a natural charge itself, but the orgone accumulator, whatever that phenomenon is, it increases that phenomenon to the point you can measure it spectrographically. Next slide. Now here you can see another spectrograph after 41 days of charging. And you can see the control water sample is way down at the bottom. No real result when compared to the orgone-charged water. The number 3 in the upper left of that graphic is the maximum intensity for this particular spectrophotometer. Next slide. Now there's a comparable fluorescence reaction that occurs. And this is something that was quite remarkable. Letter A is our light source. For fluorescence spectroscopy, you have to get a much stronger light source. And B is the cuvette holder. We're going back to 1 centimeter fluorescence cuvettes now, ultraviolet transmitting quartz. C is the spectrophotometer itself, and again the computer at D, graphing things out. Next slide. In this particular kind of measurement, the control water and the empty fluorescence cuvette basically show the same thing. They are nearly no difference whatsoever between them. However, the orgone-charged water shows a considerable peak that you can identify, and that's what you see here in a period of 12 days of charging. This is one representative example. There's a peak starting around 280 to 500 nanometers as seen in the upper left. And as you go to the middle, after 8 days of charging, the peak is still there, but now you're seeing that the effect is spreading out across the blue frequencies. And after 12 days, you can see a very pronounced near ultraviolet in the region from 300 to 400 nanometers, and then blue in the region from 400 to around 500 nanometers. And like I say, this is something that has been fairly constant and consistent. I'll have a paper that I'll be writing on this that can go into some of those details. But again, this is orgone-charged distilled water minus an uncharged control sample over these different periods. And this is using only a deuterium ultraviolet bulb, so there may be a little bit of light scattering, but it isn't much, because if it was, then the control water sample would show it as well, and we do not see that as the case. Next slide. Now, this is a satellite image, and it's a satellite image showing the west coast of the United States, and you can see there's this big cold front, that blue line with the crosshatches, showing a cold front moving into the Pacific Northwest. The little black dot on the border between Oregon and California, that's where my laboratory is located, at a high altitude, 4,300 feet elevation. That's about 1,350 meters. And you can see these 3 low pressure centers that are coming in, and they're dragging an enormous amount of rain through. So this is a good, vigorous Pacific Ocean rainstorm, and snowstorms come in that way as well. And what I found is that almost identical absorption and fluorescence reactions can be found in that rainwater coming off the Pacific Ocean, but only the strong storms. When you have these weaker intensity drizzles that sometimes characterize the Pacific Northwest of the United States, the effect is not observed. Next slide. Now here you can see these rain absorption signatures at the top and fluorescence at the bottom. This is one particular storm of the 20th of November 2015. In both cases, minus distilled control samples. So you can see that the fluorescence reaction of the rainwater is quite significant, and likewise with the fluorescence reaction in the lower graphic. And the lower graphic really does mimic the upper graphs I've shown to you previously on the orgone-charged water. So it raises a question: is the stronger charges of rainwater from stronger energetic storms, is this due to some kind of a cosmic energetic phenomenon? That's what Wilhelm Reich, the inventor of the orgone accumulator, that's what he was arguing, is that there is this basic cosmic energy principle that lays behind a lot of natural functions, including storms. Next slide. Here's another one, a snowstorm of December the 2nd, 2015. The snowfall was gathered in the same evaporation dishes, and it was allowed to melt inside the laboratory, and then the absorption and the spectrographic determinations were obtained. The snow reactions actually seem to be even more powerful in terms of the intensities than what we got just from the rainwater itself. So something about the freezing of water may increase the phenomenon of water structuring. Next slide. This next slide shows 2 graphics from the work and discoveries of Dr. Gerald Pollack. The reactions of water close to the Naphion surfaces, as obtained in his laboratory, are also identical to what we see in the orgone accumulator, and also pretty close to the reactions we see in natural strong rainwater. And again, these reactions of the absorption in this left side graphic around 240 through 280 nanometers. And the fluorescence reactions you see on the right side graphic, the Naphion gives off this excitation in a little bit in the near ultraviolet, but peaking out in the blues. Dr. Pollack maybe can speak about this. He told me once that they are observing this kind of blue color in the Naphion-charged water. And I also had got some interesting discussions with Meiwan Ho on her work on bio-photons, basically saying the same thing. Next slide. Now this is where it gets very interesting. These particular graphs are spectrographic signatures of water absorption and fluorescence from aqueous solutions of nucleic acids, DNA. These are the molecules of life, showing very, very similar, if not identical, spectrographic signatures. On the left side is the absorption, showing again from around 240 to 280 nanometers, and the right side graphic showing the fluorescence starting around 300, going off into 400 and 450, being the near ultraviolet and the blue frequencies. So this is very interesting. I found several research papers on this confirming this effect. They're all relatively recent, within the last 10 years or so. Next slide. Again, on the left, absorption, on the right, fluorescence of aqueous solutions of DNA. And the references from these are on the PowerPoint. You can get them later. Next slide. Here I want to revisit the issue of Rayleigh scattering. Is this the only explanation for these blue phenomena we see in nature? When we're seeing this in rainwater, we're seeing it in DNA, the molecules of life. We're seeing it in orgone energy charged water, which is a big controversy I realize most people have no idea about. But all of this stuff ties together and argues, in my opinion, that there is a commonality to cosmic phenomenon that affects water and thereby creates the water structuring in nature as well as in these laboratory examples where so many of us have been working. Next slide. Here's another proof from Wilhelm Reich. The little blue glowing ovals that you see here are what he called bions. And this is a radiation coming from quartz sand heated to red-hot incandescence and then placed into distilled water samples. So here you've got something that comes out of disintegrating quartz rock, and it shows this kind of bluish phenomenon. It's actually one of the first things that Reich pointed to. He was arguing that this radiation that came off of them had an intrinsically blue color. Next slide. Here's another discussion of Reich's orgone accumulator, which has nothing to do with the blueness per se, but it argues that whatever this phenomenon is, it is intrinsic to life such that certain kinds of injuries, certain kinds of diseases can respond to applications of it through the orgone accumulator that are really quite profound and inexplicable from classical theories of biochemistry. So, for example, Reich and his followers were able to show all kinds of biological and medical effects using the orgone accumulator. I've been able to show these effects with plants, with growth of seedlings increased quite dramatically. Reich was able to show that cancer mice live 2 to 3 times longer, 200 to 300% longer than controlled cancer mice. And that is really quite astonishing. If you had some pharmaceutical industry was talking about a drug that would cause a 20 or a 30% increase in longevity of mice, it would be headline news all around the world. Well, here Reich was getting 200% to 300% increase in longevity of cancer mice. And the reaction of the world was to slander him and burn his books and let him die in prison. Absolutely horrible, but it certainly reflects the historical pattern that when somebody really finds something quite important, everybody turns against them. And I don't know of any cases of book burning in the history of science where meaningless books were burned. It seems like the only books that get burned are the important ones. Next slide. This is a picture of one of the runs of seed sprouting at my laboratory using standard mung beans. The dish on the left is grown inside the orgone-accumulator. The dish on the right is grown inside of a cardboard box under controlled light and temperature conditions. And in that particular study, over 4 years of work, I was able to show a 35% increase in the growth of these mung beans over to control with a very high level of statistical significance. Next slide. Other proofs of Reich's work I've already covered in prior presentations to these water conferences. The PowerPoints for those can be found at the water conference website just by going back to the different years and looking for my papers. But they include evaporation suppression effects of the orgone-accumulator with a dependency upon local weather. Again, whatever this phenomenon is, this cosmic phenomenon, it interacts with water in a very profound way. Also, the increases of electrical charge density within the interior of the orgone-accumulator to the point where it will suppress the discharge rate of a standard electroscope over what happens outside of it. Also, slight heat production inside the accumulator correlated with non-thermal solar emissions, such as sunspot numbers, proximity of the sun to the zenith position in the sky as opposed to the 3 to 4 o'clock time of day when you usually get a peaking of your local temperature. And things like increased count activity in Geiger-Müller countertubes and other kinds of phenomena in high vacuum, also correlated to sunspot activity. The orgone-accumulator shows all these and a whole lot of very interesting similar phenomena. Next slide. Here's a couple of high vacuum tubes evacuated down to about half of a micron pressure or better. The top is Wilhelm Reich's photo from 1948. I was able to get a similar effect, as you see in the lower photo, in 2002. So it's a similar blue fluorescence, or lumination as he called it, in high vacuum tubes charged up inside the orgone-accumulator. Next slide. Finally, I want to leave you with this picture, this remarkable picture from Kitt Peak Observatory of M31, Andromeda Galaxy. And what you can see, hopefully it'll show up on the slides that you're looking at, is a blue finger of light that moves up from the core of the galaxy out into space and connects it to partner objects that are both above and below the plane of the galaxy. There are areas of very dark jet black at the very, very top of this image, but the open space itself is glowing blue. Now, I've asked the astronomers, several different astronomers, what is that? And I only got silent treatment. They never responded to my inquiries. But I do remember when the whole theory of dark matter was being discussed, that people in astronomy were pointing to these blue areas of open space as a visual representation of dark matter. And if that's the case, it's really quite remarkable. But I think what we're dealing with are two different diverging theories. The whole idea of dark matter comes from a necessity of the Big Bang theory, which I don't accept personally. I think it's deeply flawed because space is filled with energy, and once you start talking about space being filled with energy, then suddenly all of the major theories of astrophysics start having big problems. But could this be some kind of cosmic water out there in the open space? This is a double heresy, I'm sure, but what's giving that blue fluorescence? That's a very interesting question. Next slide. So I want to summarize. Orgone-accumulator water shows ultraviolet absorption signatures across 240 to 280 nanometers and fluorescent reactions 300 to 500 nanometers. This is similar to spectrums of exclusion zone water, easy water, of vigorous rain and snowmelt, and of aqueous solutions of nucleic acids and DNA. And point 3, orgone-accumulator charged water gains these spectral properties without direct physical contact with anything other than the glass dish and the atmosphere inside the accumulator itself. So what we're dealing with the accumulator is proof that this phenomenon can be induced into water without direct contact. It can be done by radiant field effects, which are suggestive of a cosmic energy parameter. Now, this is Reich's orgone energy, similar to older ideas of cosmic ether, but merged together with the concept of life energy. And life energy has a history of controversy in the biological sciences, just as cosmic ether does in astronomy. So I would think that both of these theories and both disciplines really need to rethink what's going on, especially given the dead-endedness of many of their standard theories. Next slide. I will end with a postulate. Does exclusion zone water and orgone-charged water have a spiral form molecular structure similar to nucleic acids and DNA? You know, we have to ask, what is it that's going on at the molecular level that begins to affect light frequencies when they shine through the water? We've normally thought about water structure as piling on like poker chips, one on top of the other, or something similar, building up long chains of stacks of molecules. But I would like to propose what we're dealing with here are spiral form structures, such as in DNA, such as in good life-promoting rainstorms, and such as with the life-promoting effects of the orgone accumulator itself. We can ask the question if all of these phenomena, DNA included, are shaped into spiral forms by a deeper cosmic life energy function. In other words, is biochemistry subordinate to a more primal cosmic life force in nature, which has been termed the cosmic ether, it's been termed life energy. Acupuncture and Chinese medicine calls it qi. In India, it's called prana. There are 100 names for this across different cultures, although scientifically it's been advanced mostly by people like Wilhelm Reich, and I would say that Jacques Benveniste and a few others, Dr. Pollack, and my own line of research is adding a lot of detail to this, which I think can be explained by more non-conventional theories than by the conventional ones. Next slide. And that's all. Well, I thank you very much for listening, and I'd be happy to entertain any questions or discussion at my email. You have it there on the slide and in the PowerPoint. And thank you once again for listening.